Okay, kids, today we're going to start two sections that are very, very much related. One is called exponential growth, and the other is called exponential decay. In both of these functions, the variable occurs as an exponent, and the number that's being raised to the power determines whether the values are growing exponentially over time or if they're decreasing. And of course, if they're growing, it's a growth function, and if they're decreasing, it's a decay function. So take a couple of minutes, copy down what you see, and then we'll discuss this. Okay, it says, let x be any integer, and let a be greater than 0 and b be greater than 1. Then y is equal to a times b to the x is called a growth function. In Algebra 1, you did some problems like this with exponential growth. They would give you an amount of money. Say they gave you, I'm not getting this to work here. Hang on 1 minute here. There we go. Okay, let's say that you were given $10,000 and your grandparents are leaving it for you. And so you want to put it away for college, or your parents put it away for college maybe when you were 5 or 6 years old. So you put it in an account and you ended up getting 4% interest a year. I don't know if you remember doing these in Algebra 1. And they ask you, how much is the value of the account in 10 years? And so you would go ahead and type in 1 400 times a raised to the 10th power, and then you would multiply it times 10,000 and you would get a number. Well, this right here is the same thing as saying b greater than 1. Anytime you are multiplying a number greater than 1 to a power, it's going to keep getting bigger and bigger and bigger. Anytime you multiply a number that's less than 1 or between 0 and 1, the number gets smaller and smaller and smaller as you raise it to a power. And so just using this example, if we take 1 400 and raise it to the 10th power, we get a number approximately 1.5. Approximately 1.5. If we go to two places, I believe it comes out to this. And then when you multiply that times 10,000, you end up with approximately $14,800. And so if you were to invest $10,000 for 10 years, just let it sit in the bank, at 4% interest, you'd have almost $15,000 saved. And this is what people do when they come into money through an inheritance or just investment. They take it, they put it somewhere in a fixed account, they let it earn that interest each year, and so the first year they get 4% interest of $10,000. And then the next year they get 4% interest on the $10,000 plus the previous interest. Compounding is getting interest on your interest, and it's the way a lot of millionaires do business. They invest their money and let their money work for them instead of working for their money. Now, we're going to graph exponential functions today, and we're going to show you how they work. And they're going to look sort of similar to the square root function, but they're going to be a little more drastic in terms of how the numbers get bigger and bigger and bigger over time. What you're going to do, you're going to use a roster and plot 5 points. You're going to plot the points, You're going to determine the end behavior of the graph. You're going to see what happens as the exponent gets larger and larger and larger. And then you're going to identify what they call the asymptote of the graph. Now, I'm going to talk about this in class. The asymptote is the line, a broken line, we've dealt with these before, that is basically a limit to what the value of the function is going to be. In other words, you're never going to get past that. I always tell kids, asymptotes are like invisible fencing for numbers. You're going to get closer and closer and closer to that asymptote, but you're never going to cross it. You can't cross it. And so we're going to identify what the asymptote is and see just how close our graph gets to that line as x gets larger and larger and larger. Now, last thing we want to talk about, and again, feel free to copy this down as well. You can take a minute or hit pause. It's the interest that we can calculate daily or quarterly on a loan. Most banks nowadays, almost all of them, offer savings accounts where the interest is compounded each day. Excuse me. So at the end of each day, the bank has a computer program that will allow you to take the amount of money that you have earned, and they calculate the interest. Now, right now with this economy, the interest isn't that great. But for example, we'll just put some numbers in here. Let's say, again, that you were going to invest, or you had $10,000 in the bank. So that is the equivalent of P in this formula. And let's say you were going to calculate the interest. Let's say the interest was 2%. So that's going to be a decimal, 200ths. And let's say that the interest is calculated quarterly. Now, quarterly means, of course, we don't do this anymore, but quarterly means the interest is done 4 times a year. So at the end, March 31st, your interest would be calculated. And then June 30th, your interest would be calculated. And then September 30th, and then the December 31st. So if you're calculating it 4 times a year, you're not getting 2% every day on your interest. You're getting 2% 4 different times a year. And then this number now would tell you how many times you compound it. In other words, if t is 1, and you're only going to do this for 1 year, then it's going to compound 4 times, as I mentioned. If you want to do this for 2 years, it's going to compound 4 times the first year, and then it's going to compound 4 times the second year. You're going to end up with 8 total compounds. So let's just use the 4, and let's see what happens here. I'm going to go inside the parentheses, just like I would normally do for order of operations, and I'm going to type in 200ths divided by 4, and I'm going to add that to 1. And when I do that, I get 10,000 times 1 and 5 thousandths. I'm going to fix this a little bit here for you. And that's going to be to the 4th power. So it's very similar to the other formula. The only difference with this is it allows you to choose how many times you want to run this interest generator. So I'm going to take 1 and 5 thousandths, excuse me. I'm going to raise it to the 4th power, and I'm getting something in the neighborhood. Again, if we go a couple of places near cent, it's going to be 1 and 200ths. Notice that's not much different than the original 2% interest that we were talking about. And the reason is it's only compounded 4 times. If this was compounded every day, you could see how 2% compounded every day would be a lot different. If you took 0.02 divided by 365 and then raised it to the 365 power, you would see definitely a bigger difference in the amount of interest you're getting. That's why compounding more often is always beneficial to the investor. And now you multiply this number times 10,000 and you end up with approximately, again, $10,201.51. So here we go. Whoops, sorry, $10,201. And if you have a calculator at home, you can see that. And so you put $10,000 in the bank, 2% interest doesn't sound like a lot, but if it was compounded only 4 times a year, you would get slightly more than $200 for just leaving your money in the bank. We'll talk more about this tomorrow. We'll talk about decay tomorrow. Now, decay is when the original amount drops as a result of a lower percentage. And an example of this, we'll talk tomorrow, would be the depreciation of an automobile. You buy a brand new automobile, it costs $10,000, $12,000, $15,000. Each year you own that car, it's worth less than what it was the year before. It might only be worth 90% of its value. So for example, a car that's $10,000, if it's only worth 90% of its value, the next year it's only worth $9,000. The year after that, it's worth 90% of $9,000. The value keeps dropping every year. That would be an example of depreciation. So growth deals primarily with inflation and investing. And decay can deal with certain aspects in the science field. You've heard of the half-life of certain elements, and you've heard of depreciation for the value of some cars or other things you might own. That's what we're going to work with tomorrow. Not only growth, but also depreciation. Have a great night. I hope you enjoyed it. We'll talk to you later, kids. Bye-bye.